To find where the image forms for a pair of refracting surfaces, in other words, for a lens, we're going to make use of the equation we found in the refraction at a single surface and just combine those for two things. So one thing to consider is that the image at the first surface is then going to be used as the object for the second surface. So we're going to go ahead and make use of this equation that we found. And here we have a situation where I've got some lens of thickness t, and this right here is the distance between the first refracting surface and the object. Here is that image distance, and then that image, which is formed right here, is going to end up being the object for the second lens. So this right here is my object distance for the second surface, and then this is the location of that image. So we're assuming that the material on either side of the lens is the same, has the same index of refraction. The lens itself has index of refraction n2, and then the radii of curvature of the two surfaces are r1 and r2. So writing out the equation for refraction at a surface for the first surface, we get this equation here, which I can then I'm going to go ahead and rewrite the equation for the refraction at the second surface and rewrite it in terms of n2 over s2o. And here's the reason why. This is going to get plugged in for this because the location of the image from the first surface becomes the object of the second. And so we're going to go ahead and combine those two together. The other thing I'm going to assume is that the thickness of the lens is much, much less than any of the other distances involved. This is why it's called a thin lens. In that case, if that lens is really, really small, then the image distance, S1I, is approximately equal to negative the object distance. That negative sign is coming from the fact that the object here is to the right of the surface, which corresponds to a negative value. So essentially what we're doing is we're saying that this part of S1I is negligible, in which case these two distances are essentially the same thing. So with that, I can go ahead and plug this in directly over here, just replacing S1I with negative S2O. And then we're going to go ahead and rewrite things a little bit in terms of this distance, and then I'm going to recognize that S1O and S2I, in the case of a thin lens, are essentially the object distance and the image distance. So essentially what we're doing is we're measuring our distances from the center of the lens and ignoring the fact that these surfaces induce a little bit of thickness. So what we can guess then is that this is essentially 1 over the focal length for this lens. And so if we make this connection right here, sure enough, we end up with the lens maker equation that we're used to seeing. 1 over the object distance plus 1 over the image distance is equal to 1 over the focal length of our lens.